Hello and welcome to review quiz 1, the citation session. So find the derivative of g of x equals to x exponential to the power of x power 8. So in this case, we have two functions multiplied together. So we can use a formula u of x and v of x and find the derivatives. So you get product rule gives you answers u prime v plus v prime of u. So we let u of x, a function of x, to be x and v of x to be exponential x power 8. So the derivative u prime of x will be equals to 1 and v prime of x. For this case, we use chain rule, and as we said in class, just remember this one is easy. Just have the original function x power exponential power x power 8, then you multiply by the derivative of the power of exponential. So the derivative there is just 8x to the power of 7. Then after that, you put them in the formula for the product rule. So u v prime becomes u prime, which is 1, v, that is exponential power x power 8, plus v prime u, that is 8x power 7 exponential x power 8. And don't forget to multiply by u, which was x. This one becomes exponential power x and x power 8. You factor it out, so you'll be left with 1 plus 8x to the power of x power 7 times x is x power 8 by the rules of indices. That's the answer for number 1. Let's go to second question. It's let f of x be the square root of 1 plus square root of x inside the root sign, and observe f of 9 equals to 2. So in short, we have the coordinate x is 9 and y is 2. So y being, so we need to check that indeed that y equals to 2. So we just substitute. So y equals to the big square root sign, 1 plus square root of 9, which becomes 1 plus square root of 9, which is 3. That is 1 plus 3, and the root sign, that's 4. This one becomes 2. Then, without finding the inverse function, determine the derivative of the inverse at that. So, what we do is we recall something that if y equals to f of x, or what you are doing, if the function is injective, so we get that x equals to f inverse of that. So the 2 we have here, it's our y, and we use the inverse function theorem formula. That is f inverse, its derivative, is equals to 1 over derivative of this function at x. So we're supposed to find the derivative of this function, f prime of x. So we have, it's the derivative of this function, which is not complicated. So we find its derivative. And we can write this one as 1 plus x to the power of a half, then everything to the power of a half. And then we use the chain rule, which says we consider the inner function as 1, so we call this function, we can let it to be u. So we say u to the power of a half. So this is a function of u. And then if you are to do the derivative, f prime of x, we start by du dx. So sorry, we find this derivative, that is a half, u to the power of minus a half. That's the derivative. That is df du, then du dx. So that's the last part, u prime. which just becomes derivative of what is inside, which is my u there. And the u is 1 plus x power a half. So it's a half x power minus a half. So this one, if you arrange it well, you get a half times 2 times another half. So that's 1 over 4. Then all these functions, because of the negative exponent, if you do the reciprocal, you get a root of u times root of x. That is, by doing the reciprocal, you get rid of the minus sign. So you get 1 over 4. Let me extend this one to get root of u. And u, if you check there, it was 1 plus root of x. Then you multiply by the root of x. If you substitute the x, you get 1 over 4 times 1 plus root of x, which is 9. So you get 1 plus, that is 2, then you multiply by 3. So you get 1 over 24. Sorry for having all these written in the same place, 1 over 24. So that is f prime of x. But if I was to highlight this formula here, we need to find the derivative of the inverse. So you need to take 1 over f prime at 9. So the answer becomes 24 because of 1 over that. Let's do number 3. So let me clear this notation here. Notation. So let me clear this one. And it's 24, so move it up. So you get this answer here becomes the f inverse at that. So let me squeeze it here. F inverse derivative when that y is equal to this 1 over whatever you've gotten. So it's 1 divided by 1 over 24, which is just 24. That's the answer for that question. Now, number 3, evaluate the integral of 2t over 1 minus 6t squared with respect to t. So we use u substitution, which says, so if you look at this function well, so you find that the function, if you set u to be the denominator function in this rational function, that is u, to be equals to the gt, what is in parentheses, and then the gt, if you call this one 1 minus 6t to be your gt, then du will be equals to minus 12t with dt. Now, using this formula, so we have everything in terms of t. Now we want to change the variable t to variable u. So we have the integral first. Let's try and write it and then change all the variables from t's to u's. 1 over 1 minus 6t squared is equals to my u. Then the next step is to use this part, the second part, and we can isolate dt by dividing by minus 12t on both sides to get du over minus 12t. So this next step becomes integral of 2t, but now my dt is du over minus 12. Then you divide all that by u, minus 12t, sorry. So this one results to, t will cancel, and 2 will cancel. You get minus 1 over 6, which can be factored out. Then you're integrating u with respect, 1 over u with respect to u, which is just minus 1 over 6 natural log. And remember, because of the domain of the function, this has to be absolute value plus a constant c. That's the answer for number 3. Let's go to number 4. Compute the derivative for f of x equals to 2 sine x, and then the other is multiplied by the logarithm of x base 3. So we have two parts of the function. I can call this one u and this one v. Just as I said in the first question, we use derivative of two functions multiplied together is equals to u prime v plus v prime u. If my u is 2 sine x, and so the derivative of this, we have a formula, but let me write it here. U prime, if u is equals to a constant, let me call the constant b, and then to the power of a function of x, then u prime is equals to, I showed you, it's ln of b multiplied by the derivative of the function, which is the power, then you attach the original function the way it was. Sorry, this is b, f of x. So my u in this case is ln of the constant, which is given ln of 2, multiplied by the derivative of sine, that is cosine of x, then attach the original function, that was times 2 sine x. There's another derivation, but I don't have to do derivation for now here. So the other one is v. V log base 3 of x can be written as natural log of x divided by natural log of 3, just from what I showed you in the derivation in our notes. And then the derivative, 1 over ln of 3 is a constant, so you can factor it out. And then the derivative, so I'm now working with derivative. The derivative now of ln of x is just 1 over x, just using chain rule. So this one becomes 1 over, I like arranging it in this form, 1 over x ln of 3. And then you remember the formula. That means that f prime of x is u prime v. U prime, it's the ln 2 multiplied by cosine of x multiplied by 2 sine x. Then attach log base 3 of x, then plus 2 sine x, then attach the derivative here, which is 1 over, so you can divide here by x natural log of 3. And that marks the end of that question. For number 5, so we have only one question for the recitation remaining. So number 5, it's the derivative. And now this one, we use what we call logarithmic differentiation. And this logarithmic differentiation, we start by, this one is y equals to tangent x, it's to the power of 3 over x. So we introduce log on both sides. So natural log of y equals to natural log of tangent of x to the power of 3x. Then from there, using the properties, we have natural log of y equals to, we drop 3 over x, natural log of tangent of x. The derivative, now here we applied implicit differentiation, whereby we will consider y as a function of x. So that means this one becomes derivative of this one. If it was x, it would have been 1 over x. That means 1 over y. Then you attach, don't forget, derivative of y, or with respect to it, that's y prime. Because now we use the product rule for the right-hand side. And 3 over x can simply be written as, let me write it, 3 over x can simply be written as 3 times x power minus 1. This is the same as 3 times x power minus 1. If you write it in that form, it's more easier to do this one than 3 over x, because you need to use quotient rule here, but 3 times x power minus 1 is just power rule. So let me use this one because it's the same. And I'll drop a minus because that's a power 2 minus 3x power minus 2. Then attach natural log of tangent of x using the product rule technique plus the way it was 3 over x. Then you multiply by the derivative of natural log of tangent of x. And as we know, it's just the derivative of the function which is in, and derivative of tangent of x is secant squared of x, as we said in class. Then you divide by the original function as tangent of x. So rearranging it to be more neat, we have this left-hand side is y prime over y equals to minus 3 over x squared, natural log of tangent of x plus 3 secant squared x divided by x tangent of x. Then after that, because we want to find the derivative, so we'll be left with y prime or f prime of x is equals to multiply by y across. So we have minus y times minus 3x squared plus natural log of tangent x plus 3 secant squared x divided by x tangent of x, all that under parentheses. And then you substitute y with the original function, which was y was equals to tangent x raised to the power of 3 over x. And then you put everything inside this big parenthesis there. Finally, it's find the derivative of f of x equals to exponential raised to the power of x cubed minus sine x. So this one is like a bonus. It's easier because you find f prime of x equals to just like the way function was before, minus sine x. And then after that, you multiply, because it's a chain rule, you multiply by the derivative of the power function. And the derivative power function is just, you can write it here, x cubed minus sine x, its derivative. Now find the derivative of that, which is equals to 3x squared minus cosine of x. And then parentheses, you multiply by exponential power x cubed minus sine x. That's the end of the recitation.